In this video, we demonstrate the utilization of the Xeus Xenon Hyperpolarizer automated sequences. Here we use the spin exchange optical pumping SEOP initialization sequence to prepare the device for the SEOP process. The purpose of this automated sequence is to bring the device online by powering on all essential instruments and setting their operational set points and powering up the laser safely. The sequence monitors the process through IR spectroscopy to ensure that the laser reaches the rubidium D1 resonance of 794.75 nanometers. The laser's output frequency is correlated to the water temperature. Once the laser has been brought up to full power, 40 amps, the system waits 5 minutes to allow for thermal equilibration between the laser and water chiller. The next step in the sequence is to verify a laser stable state. This is achieved using IR spectroscopy. It will perform measurements of the laser output frequency every 30 seconds until it can verify 3 consecutive measurements which fall in the permitted range. A total of 16 attempts are allowed for this process. If a laser stable state is not found, it will default in an error and shut down the polarizer safely to prevent any damage to the laser. The next step is to acquire a cold cell IR measurement, which will be used during the SEOP process to calculate rubidium polarization. With the initialization sequence complete, the device is now ready to begin the SEOP process. During this process, the set point temperature to heat the SEOP cell is set. This sequence consists of 43 loops timed at 2-minute intervals. This interval can be adjusted in the parameter menu of the device. During this interval, the device will perform in situ NMR polarimetry to determine the level of polarization of our xenon gas, then display a buildup curve, followed by an IR measurement of the hot cell, which is used to compare to the cold cell measurement taken in the previous sequence in order to calculate the rubidium polarization level. The user can exit this loop at any time if they are satisfied with the level of achieved polarization. The next step in this sequence is for the user to select whether they would like to transfer the polarized gas or to shut down the device. In this example, we will shut down the device. However, if the transfer sequence is selected, the system will proceed to prepare the gas lines and the sample container for transfer by purge, cycling with nitrogen gas. Once the cell is cooled, the polarized gas is transferred, and the system then proceeds to refill the cell via automation. When selecting the Restore Default State option, the system executes the shutdown of the system. Firstly, the laser power is lowered, and the SEOP cell temperature is set to 20 degrees Celsius and turns on all cooling fans. Once the transfer temperature of 42 degrees Celsius is reached, the sequence proceeds to the next step of powering off the laser, followed by all other instruments, including the cooling fans. This sequence is designed to safely power off the device without manual input from the user. Since the polarized xenon gas was not transferred in this example, we can now use the automated sequence to perform a timed polarization decay measurement. During this sequence, only the electromagnet is turned on set to the xenon frequency. In situ NMR polarimetry is performed at timed intervals, and the data is plotted and fit to an exponential decay to obtain the in-cell T1 measurement. This value is helpful in determining the relative health of the rubidium in the SEOP cell. Short T1 values indicate rubidium oxidation. For more information about this product and others, you can visit our website at www.xeustechnologies.com or contact us directly.